You think you can win. You think with enough effort, enough energy, enough ingenuity, you can build something that lasts forever. A perfect machine, a stable system, a civilization that endures. But you can't. Not because you're not smart enough, not because you're not trying hard enough, but because the universe has a law that forbids it. A law more fundamental than gravity, more inescapable than the speed of light. The second law of thermodynamics: entropy always increases, and entropy always wins. I'm Leonard Susskind, and I've spent 50 years thinking about the laws of physics, about what's possible and what's forbidden. And the second law of thermodynamics is the cruelest law in the universe. It says that everything you build will fall apart. Everything you organize will become disordered. Everything warm will grow cold. Everything structured will dissolve into chaos. Not might, will. Entropy doesn't just usually win, entropy always wins. Let me show you why. Let's start with what entropy actually is. Most people have a vague sense that entropy means disorder. That's not wrong, but it's incomplete. Entropy is a measure of the number of ways a system can be arranged microscopically while looking the same macroscopically. Think about a deck of cards. If the cards are perfectly ordered, ace through king, in each suit, there's only one arrangement that looks like that order, one microstate. But if I tell you the deck is shuffled, there are billions of arrangements that all look equally shuffled. Billions of microstates. The shuffled deck has higher entropy than the ordered deck. Entropy measures possibilities. The more ways something can be arranged while appearing the same, the higher its entropy. And here's the key. If you have a system and you let it evolve naturally, it will move toward the arrangement with the most possibilities, toward higher entropy. Not because there's a force pushing it there, but because there are so many more ways to be disordered than to be ordered. Probability alone drives entropy to increase. Take a box divided in half. Put all the air molecules on one side. Remove the divider. What happens? The molecules spread out to fill the entire box. Why? Because there are vastly more arrangements where molecules are distributed throughout the box than arrangements where they're all on one side. The system naturally evolves toward the state with more possibilities, higher entropy. You will never see all the molecules spontaneously gather on one side, not because it's impossible, it's technically possible, but because it's so improbable that it will never happen in the lifetime of the universe. This is the second law of thermodynamics. In an isolated system, entropy always increases or stays the same. It never decreases. And this law is absolute. We've never observed a violation. Not once, not ever. It's been tested in every conceivable circumstance. Chemical reactions, thermal processes, black holes, quantum systems. Entropy always increases. Always. Now here's where it gets disturbing. The second law applies to everything, not just physics experiments, everything. Your body is a low entropy structure, highly organized cells, tissues, organs, working in coordinated ways. You maintain this low entropy by eating food, low entropy energy, and expelling waste, high entropy energy. You're constantly fighting entropy, constantly rebuilding, repairing, maintaining order against the tide of disorder. And you can do this temporarily because you're not an isolated system. You're extracting energy from your environment. But you can't fight forever. Eventually, your ability to maintain order fails. Cells stop dividing correctly. DNA accumulates errors. Proteins misfold. Systems break down. This is aging. Aging is entropy, and death is the moment when your body can no longer maintain its low entropy structure. When the organized pattern, that is you, dissolves into thermal equilibrium with the environment. Death is entropy winning. But it's not just individuals, it's civilizations. Every civilization that has ever existed has collapsed. Egypt, Rome, the Maya, countless others. Why? Many immediate causes. War, disease, environmental collapse, but underlying all of them is entropy. Civilizations are low entropy structures, organized systems of people, infrastructure, knowledge, institutions. Maintaining this organization requires constant energy input. Agriculture, trade, innovation. The moment a civilization can't maintain its energy input, entropy takes over, infrastructure decays. Knowledge is lost, organization breaks down, civilizations don't just decline, they dissolve, their information scatters, their structures crumble, entropy wins. And this will happen to us too. Not might, will. Every building we construct will eventually collapse. Every book will eventually rot. Every digital record will eventually corrupt. Every monument will eventually erode. Entropy guarantees it. Let me make this concrete. The universe is 13.8 billion years old. In the beginning, at the Big Bang, the universe was in an extremely low entropy state. All the energy concentrated, all the matter in a tiny volume, highly organized. Since then, entropy has been increasing. Stars form, burn, and die. Galaxies spread apart. The universe expands and cools. And this process continues. In about 5 billion years, our sun will exhaust its hydrogen fuel. It will swell into a red giant, engulf the inner planets, probably including Earth. If we're still here, we'll have to leave. But where will we go? Other stars will also die. In a few trillion years, all the stars in the universe will burn out. The night sky will go dark. No more starlight, no more new stars forming, just cold, dead remnants. White dwarfs, neutron stars, black holes, and even black holes don't last forever. Stephen Hawking showed that black holes evaporate through quantum radiation. Slowly, incredibly slowly, but inevitably. A solar mass black hole takes 10 to the 67 years to evaporate. Supermassive black holes take even longer. But they all evaporate eventually. And when they do, what's left? Nothing but a thin soup of particles spread across an expanding universe. Photons, neutrinos, maybe some electrons and positrons, all at nearly the same temperature, nearly 0 Kelvin, no structure, no organization, no life, just maximal entropy, thermal equilibrium, heat death. This is the ultimate fate of the universe according to thermodynamics. Heat death, the state of maximum entropy where nothing can happen because there are no energy differences to drive processes. The universe doesn't end with a bang. It ends with a whimper, with a cold, dark, empty eternity where entropy has won completely and permanently. Now you might object. You might say, but we see order increasing all the time. Galaxies form, stars ignite, planets coalesce, life emerges and becomes more complex. Humans build cities, create art, develop technology. How is that increasing entropy? The answer is that local entropy can decrease if you have an energy flow. Earth decreases its entropy by increasing the sun's entropy. The sun burns, converts ordered nuclear fuel into disordered radiation. That radiation flows outward, increasing entropy. A tiny fraction hits Earth and powers life. Life uses that energy to build structure. But the total entropy of the Sun-Earth system increases. The sun's entropy increases far more than Earth's decreases. The second law is never violated. It's just that systems with energy flowing through them can temporarily build order by exporting entropy. But here's the key word, temporarily. Every structure is temporary. Every decrease in entropy is local and transient. The overall trend is always toward disorder, always toward heat death. And there's no way around this, no loophole, no clever trick. The second law of thermodynamics is derived from statistics and probability. As long as systems have many possible microstates, entropy will increase. You'd need to violate basic probability theory to violate the second law. Some people have tried to imagine ways around it. Maxwell's demon is a famous thought experiment. Imagine a tiny demon that watches molecules in a box divided by a door. When a fast molecule approaches from the left, the demon opens the door and lets it through. When a slow molecule approaches from the right, the demon opens the door. Fast molecules accumulate on the right, slow molecules on the left. You've separated hot from cold without doing work. You've decreased entropy, you've violated the second law, except you haven't. Because the demon needs information. It needs to measure which molecules are fast and which are slow, and that measurement process generates entropy. The act of acquiring information, of recording which molecules are which, increases entropy somewhere else. When you account for the demon's memory and the thermodynamic cost of erasing that memory, the total entropy increases. The second law is saved. This was proven rigorously by Rolf Landauer in the 1960s. Erasing information has a thermodynamic cost. Deleting one bit of information increases entropy by at least k log 2, where k is Boltzmann's constant. Information and entropy are connected. Every time you erase information, you generate heat. Every time you process information, you increase entropy. Even computers, even thinking, even consciousness itself increases entropy. There is no free lunch. There is no perpetual motion. There is no way to beat entropy. Now let me tell you about something deeply strange. Time. Why does time flow forward? Why do we remember the past but not the future? Why do causes precede effects? The answer is entropy. The arrow of time, the direction from past to future, is the direction of increasing entropy. We remember the past because memories are low entropy records formed by interactions that increase total entropy. We don't remember the future because the future hasn't created those records yet. Causes precede effects. Because causal processes increase entropy, the effect has higher entropy than the cause. If entropy were decreasing, time would appear to flow backward. But entropy always increases, so time always flows forward. The flow of time is not a fundamental feature of the laws of physics. Newton's laws work the same forward and backward in time. So do Maxwell's equations, so does Schrödinger's equation. The fundamental laws are time-symmetric. But the universe is not time-symmetric because entropy is not symmetric. Entropy increases in one direction only, and that direction defines the future. This means the arrow of time is a consequence of the Big Bang. The universe started in a low entropy state. Why? We don't know. That's one of the deepest unsolved questions in physics. But given that it started with low entropy, entropy has been increasing ever since, and it will continue increasing until heat death. The entire history of the universe, all 13.8 billion years and all the trillions of years to come, is just entropy increasing from the Big Bang to heat death. We live in the middle of that process. In a brief window where entropy is high enough for structure to exist, but low enough for energy gradients to drive interesting processes, this window won't last. It's already closing. Star formation peaked about 10 billion years ago. The universe is already past its prime. Fewer new stars form each year. Galaxies are spreading apart. The universe is darkening and cooling, and this process is accelerating. We recently discovered that the expansion of the universe is accelerating. Dark energy, whatever it is pushing galaxies apart faster and faster. This means the universe will expand forever. It won't collapse in a big crunch. It will spread out indefinitely, becoming ever colder, ever darker, ever emptier, entropy maximizing across an infinite volume. There's no escape from this, no way to reverse it, no place to hide. Some people imagine advanced civilizations could fight entropy indefinitely, build massive structures, harness black holes for energy, survive for trillions of years. But you can't fight entropy forever. Every process generates waste heat. Every computation increases entropy. Eventually, you run out of free energy. Eventually, everything reaches thermal equilibrium. Eventually, entropy wins. Always. There's a concept in thermodynamics called free energy. It's the energy available to do useful work. As entropy increases, free energy decreases. The universe started with maximum free energy concentrated at the Big Bang. It will end with zero free energy spread across infinite space, and we're witnessing this transition. Every time you turn on a light, you're converting free energy into waste heat, increasing entropy. Every time a star burns, it's converting nuclear-free energy into radiation, increasing entropy. Every breath you take, every thought you think, every movement you make increases entropy. You are an entropy-generating machine. We all are. And there's something profound and terrible about this. Nothing you do lasts. Nothing you build endures. Everything you create will be destroyed, not by malice or accident, but by the fundamental laws of physics. The pyramids will erode, the great works of art will decay, the books will crumble. The digital records will corrupt. Even if we spread across the galaxy, even if we colonize 1,000,000 worlds, even if we persist for billions of years, entropy will win in the end. Heat death is inevitable. The only question is when. Now here's the existential crisis. If entropy always increases, if everything tends toward disorder, if the universe is doomed to heat death, what's the point? Why build? Why create? Why care about anything if it's all temporary? This is a legitimate question, and I don't have a satisfying answer. Not a cosmic one, but I have a personal one. The point is that we exist now, right now, in this brief window of cosmic time when entropy is low enough for structure and complexity, when stars shine, when planets orbit, when life exists, when consciousness asks questions. We are the universe's way of organizing itself temporarily against the tide of entropy. We are patterns that maintain themselves for a moment before dissolving, and during that moment, we can experience. We can think. We can create. We can find meaning in the temporary. Yes, entropy will erase everything we build, but that doesn't make building meaningless. It makes it precious. The fact that structure is temporary makes it valuable. The fact that order requires constant effort makes it significant. We are fighting a battle we know we'll lose, but we fight anyway. Because the fight itself is what matters. The process, not the outcome. The journey, not the destination. This sounds like philosophy, but it's rooted in physics. The second law of thermodynamics doesn't say you can't decrease entropy locally. It says you can't decrease total entropy. You can build order here by exporting disorder there. You can create structure temporarily by expending energy. And that's what life does. That's what consciousness does. We are temporary decreases in local entropy powered by increases in entropy elsewhere. We are islands of order in a sea of chaos, and those islands won't last. The sea will reclaim them, but while they exist, they matter. Let me end with something that might be comforting or horrifying depending on your perspective. The information that makes you you, the pattern of your brain, your memories, your personality, that information doesn't disappear when you die. It can't. Information is conserved in quantum mechanics. What happens is that the information becomes scrambled. It spreads out into the environment in a way that makes it practically irretrievable. Your information joins the cosmic information sea. The specific correlations that constituted your consciousness are lost in the noise, but the information itself persists. It's still there, encoded in the particles and fields that once composed you, now dispersed throughout the universe. Entropy doesn't destroy information, entropy scrambles it. And in a sense, you never truly disappear. Your information persists forever, just in an unrecognizable form. That's not immortality, that's not resurrection, but it is a kind of persistence. The universe keeps records, and you're part of that record now and forever. This is what the second law of thermodynamics tells us. Order is temporary. Disorder is permanent. Structure is fleeting. Chaos is eternal. Everything you build will fall apart. Everything you organize will scatter. Everything warm will cool. Everything alive will die. Entropy always increases. Entropy always wins. Not sometimes, not usually, always. This is not pessimism, this is physics. The universe has rules, and one of those rules is that entropy increases. You can't negotiate with it, you can't outsmart it, you can't overcome it. You can only accept it and decide how to live in a universe where entropy wins. That's the truth. After 50 years of studying physics, that's what I've learned. Entropy always wins, but until it does, we get to exist, and that's something. Thank you for watching. Now you know why everything ends. Welcome to thermodynamics.